So we're starting Chapter 5. So let me just do a quick preview with you of Chapter 5. Alright, Chapter 5 is dealing with, we're starting to look at what are called functions. This is like the beginning of working with functions. There are different kinds of functions. There's linear functions, there's quadratic functions, there's exponential functions. We're going to be getting into linear functions first, which just means like if you draw it, it's a line, a straight line. Okay? So today we're going to be talking about functions and relations. Functions is just a fancy word for an equation. Alright? So it's nothing new that we haven't seen, we're just using new terminology. Then we're going to be getting into making tables and graphs for functions. Then we're going to be writing function rules, which are basically just equations. We're going to be writing equations. And then we're going to be getting into the very first of our linear equations. It's called direct variation. And that's about our chapter. Okay? So it's not a long chapter, it's just 5 sections. And we're starting with section 2. Alright, so this is a little bit shorter chapter than we've had in the past. Okay? So let's take a look at, we're in chapter 5, section 2. And we're going to be talking about relations and functions. Okay. Okay. A relation is a relationship between two sets of data. So relationship is a relation is a relationship between two sets of data. Right? It is written as ordered pairs. Right? We see them as ordered pairs. Our ordered pair is always x comma y. That's the same thing that we've been doing. Right. Our x information is always called our domain. So our domain is always our x info. I don't think I've used that word before, domains. Is this the first time you've heard that word from me? Okay. So domain is always your x information. It's also your independent information. It's what you're changing. You're going to hear me say that a lot, independent. Your y is always called your range. So your range is always your y info. Alright, it's always your dependent info. So, with regards to domain and range, let's talk about what, in a situation, what the heck that means. So if we talk about babysitting, let's say you charge $8 per hour. Excuse me, students, just one interruption due to the rain. We will be having indoor recess. Unfortunately today there is no gym time. Once again, we are having indoor recess in all classes. Kindergarten through 8th grade will return to their homerooms for today. Once again, indoor recess because of the rain today. Thank you. So we charge $8 an hour. How do I find how much money I'm going to make? How do I find how much money I'm going to make if I know that I charge $8 an hour? Nick? Alright, so what do I do with the number of hours I'm working? Right, we multiply by the $8 per hour, right? So if I take my $8 per hour. I'm going to write per hour. If I multiply that by number of hours, I get the total I earn. How many of you guys agree with that? All right. In this situation, we have two things we don't know. There are two things we're changing. We're changing our hours, and we're changing how much I earned. Which one of these are you changing? Which one of these sets of information are you changing? And which one of them depends on the one you're changing? Victoria? Exactly. The total amount of money that you earn depends on how many hours you work, doesn't it? Alright, so this total amount of money depends on the number of hours. So this depends on the number of hours you work. So this is your dependent info. So is that our domain or is that our range? If it is our dependent info, is it our domain or is it our range? Serena? That's our range. Which means that our number of hours, this is what we change. So this is our independent info. So is that our domain or is that our range if it is our independent info? Ashton? That is our domain. Can you kind of see the difference between these, independent versus dependent? Your dependent always depends on your independent. So, like you're going to the gym membership, you have a gym membership, all right, and you're being charged per month, $10 per month. Well, the cost of what you have to pay depends on how many months you do it, right? So your number of months is your independent, the amount of money you pay is your dependent, because it depends on how many months. How many of you guys are cool when it comes to that independent-dependent thing? I need you all listening, please. How many of you guys are cool with this independent-dependent information? Your dependent always depends on your independent. Okay, yes. Are you cool? Okay. So let's talk again. Let's go back to a relation. All right? So if we take a look at a relation, I'm going to give you an example of a relation. Who needs to see what's up there? Okay. So let's go back to an example of a relation. So let's go back to an example of a relation. All right, I'm going to show you a table. All right, I'm going to show you a table. All right, and this table is, we're talking about giraffes. All right, so we're going to talk about giraffes. So what I'm going to do is I'm going to be relating the age of a giraffe. This was done by research. So someone did some research. They took a look at the age of giraffes, and they compared it, and they measured their heights. And this is going to be in meters, and my age is going to be in years. So in this relation, God bless you, in this relation, we are analyzing the age of giraffes and their heights. That's what this table is analyzing. You're all writing this down. So what they found is, they found an 18-year-old giraffe is 4.25 meters. They found a 20-year-old giraffe was 4.40 meters. They had a 21-year-old giraffe that was 5.25 meters. And they had a 14-year-old giraffe that was 4.80
they had in their zoo that they were measuring. This is a relation. All right, because what we have is we are looking at the relationship between age and height. This is a relation. Each one of these can be written as a coordinate point. So if I was to write these as coordinate points, now here's the thing to remember. Your first column or row is always your x. On a table, your second column or row is always your y. So x, always first column or row. Your y is always second column or row. Always. So if I was to write this first data point as a coordinate point, an 18-year-old giraffe is 4.25 meters. How would I write that as a coordinate point? My first column is always my x information. My second column is always my y information. So somebody write that first relationship as a coordinate point. Matthew? Excellent. 18, 4.25. Somebody write the second one as a coordinate point. Nice job, Matthew. Victoria? Yep. Remember, they go in parentheses. Funny. 20, 4.40. Jacob, do this at the third one. Excellent. And then Colin, do the last one for me. This is a relation. It's simply a relationship between two sets of data. You guys cool so far? Questions? Yes. Yes, you might have to graph this. All right, we're going to talk about why you graph it. Right? When we're doing surveys, why do you suppose somebody is surveying giraffes and looking at their age and their heights? Why would someone do that? Nick, what do you think? How? Yeah, but why do you think the boss wants a survey analyzing age and height? Ashton? Excellent. They might be being like, okay, is there a relationship between age and height? If I know that, every 14-year-old giraffe, are they about 4.85 meters? Are we finding, as we look at 14-year-old giraffes, are we seeing that they're about the same height? A 20-year-old giraffe, are we finding that they're around all the same height? So they're probably looking to see, is there a relationship between age and the height? Right? Just like with humans, there probably isn't, right? But there might be. I don't know enough about giraffes. So that's why they're doing it. They're looking to see, is there a relationship that you can state that, like, the older they get, the taller they're going to be. And that's always going to be the case. And an 18-year-old giraffe's always going to be around 4.25 meters. All right, they're looking to see if they can say that. Okay. So I'm going to give you a table so in this situation, what information is my domain and what information is my range? So describe what it is and then tell me that what we're going to talk about, how to write the values. What information in this table is my domain and what information is my range? Serena? What information is it? It's the age. All right. If I write this as a group of numbers, all right, what are my numbers, Serena? Excellent. We usually write them in order of least to greatest, but I don't care at this point. What information is my range? Jacob, that's my height. And write that grouping of numbers for me. Tell me the range values, Jacob. Excellent. Are you guys cool with identifying domain range from a table? You guys good with that? Okay, so what I want you to do is on this one, I want you to identify the domain and range values. That's all I want you to do. All right, so here's my table. And this is one of the things I want to point out that I did not state because I didn't have it up here. Only show each repeating value once in a group. So in the last one we didn't have any repeating, but in here we do. So when you list your domain and you list your range, only show any of them that repeat, only state them once. All right, so all of you identify the domain and identify the range in this table. Come on. And you're going to do that using your brackets or your braces. These are a grouping symbol, but they're braces. God bless you. Remember, your domain is always your X information, your range is always your Y information. That's something to remember. So somebody list for me my domain values. Ashton? Yep, 4, -2, and -1. I know that there are more than one 4. I know there's more than one -1. We only want to state each one of them once. So somebody tell me my range values. Ava? Excellent. Raise your hand if you're cool identifying domain and range. Awesome. Okay. So now I need to talk to you guys about the word function. Okay? And what a function is, because from here on out we're going to be dealing with functions. Who needs to see what's up there? Okay. All right, so let's talk about the word function. A function, another word for that is just equation. It's an equation that shows the relationship between the domain and range info. It is a relation. It's just a special relation. Not every relation is a function. So not every relation is a function. There are only special relations. So I always kind of relate this to, okay, quadrilaterals, right? you've got parallelograms, you've got trapezoids, you have rectangles, you have squares. So I want you guys to think about a rectangle and a square. Is every rectangle a square? No, right? A rectangle is like the more general term, isn't it? Is every square a rectangle? How many of you guys agree that every square could also be considered a rectangle? Absolutely. Because a square is a special rectangle. What makes a rectangle a square? So why is a square a special rectangle? Isabella? Okay. All right, I agree with that. But how do I know if a rectangle is a square? What makes it a special rectangle? Jacob? All the sides are exactly the same. So, every square is a rectangle. How many of you guys agree with that? But every rectangle is not a square. We need to take a look at the rectangle and be like, okay, are all the sides the same? Okay, then it's a square. The same relationship is between a relation and a function. Every function is a relation, but every relation is not a function. So I need to know what makes a relation a function. All right, so let's figure out what makes a relation a function. And there's one thing only that makes a relation a function. We can see it in many different ways, but there's only one thing that makes a relation a function. So, relation is a function if no domain values repeat. So, a relation is a function if no domain values repeat. So if no domain values repeat, we do have a function. No domain values repeat. So I'm going to show you two tables. All right, two tables of values, and you're going to tell me if the table is a function or not a function. Are you guys with me? Okay. So what we're looking for is, do the domain values repeat? All right, so I want you to state if the following tables are functions or just a relation. All right, so here is my first table. I'm just going to give you two of them. I'm going to split my page in half. Here's my x, here's my y. -3, -2, 0, 3, 1, 2, 4, and 7. Is this a relation? Is this a function or just a relation? So function, not function. Remember, it's a function if no domain values repeat. So function or no function? Function or no function? Serena? How many of you guys agree that this is a function? Yes, this is a function. Because no domain values repeat. That is a function. All right, let me give you guys another one. It does not matter if your range values repeat. We don't care if the range values repeat. It's only the domain. So let's do another one. So let's do -3, 0,
1 and negative 3. And I have 6, 2, 3, and 5. Function, not function. Function or not function? Blythe? Why? Excellent. Our negative 3 is repeating, not a function. So not function because negative 3 repeats in domain. So one way that we can determine if it's a function or not is by looking at a table. And we can very clearly see that an x value is repeating. How many of you guys are cool with that? Okay. When we talk about functions, there are 3 different ways we can see a function, okay? And we're sticking with the same thing of function or not a function, okay? Here we looked at tables. So when we talk about functions, there are 3 ways to show a function. One is a table, and that's what we've been doing. The second one is an equation. That might be like y is equal to 3x plus 1. That would be an example of a function. And the other way to see one is a graph. I want to talk about a graph right now. Alright, we want to figure out how from a graph we can determine if we have a function. Alright, so how do we determine if a graph is a function? Well, we still don't want any domain values repeating. All right, we still do not want any domain values repeat. How do we see if a domain value repeats? How do we see in a graph if a domain value repeats? How would we see that? Ashton? Yeah, that means that we would have 2 coordinate pairs with the same x value. Alright, what we can do, so I want you guys, I know we're going to run out of time here, but I want you guys to do this graph. So I want you to make this graph. I want you to graph the same points that I'm graphing. So I'm going to put one right here. So I want you to graph those points. If I looked at this graph, how could I determine by looking at it if 2 points have the same x value? So 2 points have the same x value if think about what this coordinate point would be. What is this coordinate point if I put a coordinate point on this? This one right here. What would you say this is? Ashton? I'm sorry? Negative 2? Negative 2. 3. Someone tell me this coordinate point. Sam, what is this coordinate point right here? This coordinate point right here. How many points, how many spaces is it off the origin? So this is -1. Dude, it's going up 1 from the origin. So this is -1, 1. Are you with me? Here's my origin. Don't I go over 1 space to the left? That's -1. Don't I go up 1 space? That's +1, right? Sweet, okay. Somebody give me this coordinate point. Matthew? This one right here. Excellent. Colin, give me this point. Do I have any points that have the same x value? Yes, I do. What do you notice about those 2 points that I don't even need to write these on here? That you could be like, I know those line up. How do I know that 2, I kind of almost just gave it away. How do I know that I have 2 points that have the same x value just by looking at the graph? Jacob? They do. They line up vertically. These 2 points line up vertically. So 2 points have the same x value if they line up vertically. This is called a vertical line test. That's how we determine if it's a function or not. So, if 2 points line up vertically, is this graph a function? If they line up vertically, that means they have the same x value. So, do these 2 points, does this graph represent a function if these 2 line up vertically? Serena? How many of you guys agree that this does represent a function? All right, those of you say no. Why does this not represent a function? Blythe? Yeah, these 2 line up vertically. So these 2 points right here, they have the same x value. So 2 points have same x value. So, graph, not function. Are you guys good with that? All right, I'm going to show you another graph, and you're going to tell me if it's a function or not a function. Take a look at number 38 here and tell me, if I was to use the vertical line test, is this a function or not a function? So I want you to think about drawing vertical lines on this. Does any vertical line cross that line 2 different places? Everyone's eyes are up on the board. Function or not a function? Is there any vertical line that I draw that touches this line twice? That would mean that the 2 points line up. Colin? No. So is this a function or not a function? That is a function because there are no 2 points lining up vertically. How many of you guys can see that? Okay. How about this one? Function or not a function? Are there any 2 points that line up vertically? Nick? There are. So is this a function or not a function? It's not a function. Can you guys see the difference? Alright, so now we've looked at graphs on how to determine if we have a function or not. We've looked at tables and how to determine if we have a function or not. Alright, so tables, we look to see, do any x values repeat? Graphs, we look for exactly the same we're looking just to see, does a vertical line cross through more than 2 points of that function? There's one more. All right. Somebody super smart came up with this. I think they're smart. I don't know, but they came up with this. There's another way that we can create to determine if there's a function or not. All right. There's something called a mapping diagram. So we are going to make a mapping diagram to determine if this something is a relation is a function or not. So now we're going to use mapping diagram to determine if a relation is a function. So first we need to figure out what a mapping diagram is. So a mapping diagram, it's in table form. All right, and what we do is we list the domain and range values in a table. All right, and we connect coordinate pair partners together with arrows. So let's do this. So I'm going to I'm going to give you some coordinate points, and we're going to create a mapping diagram, and then we're going to determine how we can figure out if it's a function or not. Okay, so here are my points. 11, -2, 12, -1, 13, -2, and 20, 7. Alright, so I'm just going to take my domain values, and then I'm going to take my range values, and I'm going to put them in table form. Well, I have an 11, and I have a 2. I have a 12, and I have a -1. That's a -2. I have a 13. Well, -2 is already shown in my range. And then I have 20, and then 7. So I've just taken my domain values. I've put them in a domain column. I've taken my range values, and I put them in a range column. I've created a table. How many of you guys are cool so far? Okay, so now what I want you to do is I want you to draw arrows connecting coordinate pair partners. So who is 11's coordinate pair partner? Serena? -2. So I'm just going to draw an arrow from 11 to -2. Who is 12's coordinate pair partner? Victoria? -1. Who is 13's range partner? Nick? 7. Who is 20's range partner? Serena? No. Who is 20's range partner? 7. Oh, 13 should be -2. Gah. I listened to someone I shouldn't have. We're going back to our coordinate pairs. So it's not who's next to them, it's whose coordinate pair partner is it. Okay. This is how we determine if a relation is a function, or if a mapping diagram is a function. If more than one arrow goes out of a domain value, the x value is repeating. That's not a function. is what we're looking for. We're looking to see if an arrow goes out of a domain value, if more than one arrow goes out, it is not a function. So, if I take a look at this mapping diagram, is there any domain value that has more than one arrow out of it? Is there any domain value that has more than one arrow out of it? So I'm looking at all my domain values. Is there any domain value that has more than one arrow out of it? Jacob? No. So this is a function. Only one arrow out of each domain value. Alright, I'm going to give you another mapping diagram, and I want you to tell me. You're going to be creating mapping diagrams. Alright, so I'm going to give you another set of coordinate points, and I want you to create a mapping diagram. Okay? So if I give you... So I want you guys to create a mapping diagram and determine if the relation is a function. So here is my examples. So I have -2, -1, -1, 0, 6, 3, and -2, 1. So you're all creating a mapping diagram using those coordinate points. So I'm going to start by writing domain, range. I'm going to list all my domain values. I have -2, I have -1, I have 6, well -2 already showed up. My range values, I have -1, I have 0, I have 3, and I have 1. So there are my range values, there are my domain values. Questions so far? Yes. I know, just humor me, because if I give you one of these, you need to know how to do this. Okay. So now, what coordinate pair does -2 go with? Ava? -1. How about, so I've taken care of that one. How about my -1? Where does that go with? Serena? 0. So I took care of that one. How about my 6? What does that go with? We're looking at our coordinate pairs here. What does my 6 go with? Ashton? 3. How about this last one? Matthew? That goes with my -2. So now I need to look at my domain. Are there any arrows that come out of my domain that have more than one arrow? Are any of my domain values with more than one arrow? Jacob? Yeah, which one? Yeah, this one right here. We have more than one arrow coming out of it. So is this a function or not a function? Yep, this is not function because -2 has more than one arrow. That is a mapping diagram. So on your test, I may give you a mapping diagram that has it already made up, and you're going to need to tell me if it's a function or